For most of human history, people believed our world was truly unique. Yet as philosophy and science developed, we learned that Earth is just one of 8 planets orbiting the Sun. Over time, it became clear that our Sun is merely one among countless stars, each potentially surrounded by its own planetary system. The twinkling lights in the night sky are not just stars. Many are other suns with their own sets of worlds, some of which might even host alien life. Until recently, we knew of no planets beyond our solar system simply because we had not detected them yet. Even if we suspected that Earth might not be special, we lacked the evidence to prove it. That began to change in the early 1990s, when astronomers discovered the first exoplanets. Today, we've identified well over 3,000. Thanks to missions like the Kepler telescope, we now know that virtually every star in the sky is likely orbited by planets. On a clear night, when you look up at the stars, you can imagine entire solar systems circling each one. This leads us to wonder, how many of those planets are like Earth? Current estimates suggest that about 20 billion Earth-like worlds could exist in the Milky Way galaxy alone. By Earth-like, we mean a rocky planet situated at the right distance from its star, so that liquid water can exist on its surface. In our own solar system, Venus, Earth, and Mars all lie within this so-called habitable zone, and they once held water. Even today, we search Mars for signs of past life. Finding any form of Martian life would be among the greatest discoveries in human history. Although most scientists think any Martian life would be microbial, the prospect of discovering multicellular life, something akin to plants or animals, would change our understanding of the universe forever. Close to home, Jupiter's moon Europa is another promising candidate in our search for life. NASA's Europa Clipper mission, set to launch in October 2024 and arrive by 2030, will conduct 4 years of detailed observations. Europa likely hosts a deep ocean of liquid water beneath its icy crust, making it a prime place to look for extraterrestrial organisms. Beyond our solar system, the task becomes far more challenging. With current technology, sending space probes to other stars is practically impossible. Proxima Centauri, our nearest stellar neighbor, is about 4.2 light-years away, a tremendous distance. For now, our best strategy is to watch and listen, searching for radio signals, scanning for signs of life, and looking for biosignatures through our most advanced telescopes. The biggest prize would be finding intelligent alien life. It's often noted that a civilization only slightly more advanced than ours could colonize the entire galaxy in about 10 million years. So where are these civilizations? This question is known as the Fermi Paradox, named after physicist Enrico Fermi. Given the multitude of stars and the vast amounts of time available, why have we found no sign of advanced life? One possible explanation is the Great Filter, a critical barrier in the development of life from its simplest beginnings to an advanced, galaxy-spanning civilization. Perhaps the Great Filter is behind us, making the rise of intelligent life exceedingly rare, or maybe it's still ahead, meaning advanced civilizations inevitably destroy themselves before achieving interstellar reach. Efforts to detect technosignatures, traces of alien technology, may help resolve this. If such signatures are common, it suggests we've already passed the Great Filter. If we find life is common, but no technology, then maybe the Great Filter awaits us in the future. Some theories suggest that advanced species might abandon their biological forms altogether, becoming machine intelligences that lack any desire to colonize the galaxy. Another, the zoo hypothesis, imagines that we are being observed without our knowledge, carefully avoided like unwitting specimens in a grand cosmic exhibit. There's also a more somber possibility, that we are the first civilization in the Milky Way capable of pondering these questions, and that we might vanish long before others arise. While astronomers estimate there could be billions of potentially Earth-like planets, we have yet to find life anywhere else. On Earth, life emerged almost as soon as conditions allowed, about 3.8 billion years ago. This suggests that when the circumstances are right, life may appear readily. Yet complex multicellular life took far longer to develop, some 600 million years ago. For more than 3 billion years, Earth hosted nothing beyond simple microbes. This prolonged period of microbial dominance indicates that evolving from simple to complex life is not guaranteed, and may require extraordinary stability and luck. A crucial event in Earth's history was the emergence of eukaryotic cells, complex cells that now compose every plant, animal, and fungus. Evidence suggests this happened only once. If such rare and unlikely events are essential for intelligent life, then our world might be astonishingly special. It's even conceivable that we are the only thinking beings in the entire Milky Way. If that is true, then we humans carry an immense responsibility. As the sole known source of meaning and understanding in a galaxy of 400 billion stars, our choices matter profoundly. Destroying ourselves would mean extinguishing the only light of consciousness we know to exist in this vast cosmic darkness. Thank you for watching. If you enjoyed this video, please consider subscribing, ringing the notification bell, and enabling alerts to ensure you never miss any future content. Your support helps us continue exploring the biggest questions of our universe.